This is Jim Chastain. We're going to be talking about how to do code or how to do executable code in periodic tasks, specifically Loop A, and how to utilize robot global data in the process. Now, you need to kind of go through some of this basics with me so you don't get lost when we get into the LabVIEW stuff. In periodic task, there are a number of existing while loops. And what I've done is modify the top two and then added ones below it. And the top one, I label it Loop A, and it's where we read the joysticks and the sensors. We read all these values and store in robot global data, and it's updated frequently by changing the delay time for the loop, so that we have the most current data at all times in robot global data. You're going to see some element of signal conditioning, and we want to have minimum logic so it won't slow down the execution. Loop B is where the drive system and the switch will be if we have any automated controls. This needs to be updated frequently so that we can eliminate concerns about the watchdog timer. And in the third loop, there's going to be multiple C while loops. And this is where we're going to put new loops for state machines, new loops for scanners, or any other type of motor or actuator controls. So this session we're going to be specifically focusing on Loop A. And again, watch the use of robot global data. Write all the values as we read them and store them. Write them also to the dashboard list so that we can see them from the driver station. There's some amount of signal conditioning. In this case, we're going to do an absolute value for the encoders. And note that we also use a reset function, both gyros and encoders, that can later be switched between manual and the autonomous control. So I'm assuming that all channels have been set up correctly in begin and closed and finish. Anytime you make changes to your code, you always want to do it through the Project Explorer. So let's go back and open up a project that I've started before. In this case, it's 2019 Robot Project, Space Probe with Gyro and Encoders. I select the project, LabVIEW Project, VI. Actually, it's not a VI, it's a .lvproj. And as I open it up, it opens up the Project Explorer window. And it's through this window that we want to access or make changes through the separate VIs. We're talking specifically about periodic task, so I can double click on that icon to open up the VI. First thing we see is the block diagram, and behind that is, the front panel, which nothing really happens. Behind that we have the block diagram. Now we've set up the joysticks in a previous webinar. So what I'm going to do here is set up utilize the channels for gyro and encoder. I'm going to put my icon here for the cursor in a blank space below the code that exists. Hold down Control, left click and drag and make more room in this VI. Now I want to talk about, before I jump into making the changes, I want to talk about Robot Global Data. Robot Global Data is a very special VI, and it's located in my list in my Project Explorer, and I can bring it to my block diagram just by left clicking and dragging. The fact that this has a little globe on it tells me that it's a global data. It is Robot Global Data. So I've already used it multiple times. It doesn't have a block diagram. If I double click on this with the little arrow, I open up the front panel. And so these are the indicators that I use to set up the joystick. I need some indicators specifically for the values that I'm going to see for my gyro and my encoder. I'm going to right click, go to my numeric palette, and I'm picking up numeric indicator. Let's put one right here. Let's call it gyro angle. I want to do these in caps just so I can tell. I've got to spell it right. Spelling doesn't matter, but these are going to be hanging around for a while, so we want to get gyro angle, right click, insert another indicator, and type in encoder. So let's make this left encoder because we may have two. Now I also know that I want a reset button, and it may be manual or it may be controlled by the program at some point. So I'm going to put in an indicator for reset, and we'll deal with that later, but I know I need a reset. All right, now that I've made these entries, as long as I close this little asterisk right here at the top, means changes have not been saved. But as soon as I close it and save it, now those values will appear. If I use a white knuckle now to look at my list, those values are all on the same VI. In fact, they're on, the same robot global data. They are all included in the list. All right, robot global data is extremely valuable, and we will see that as you follow this more and more. All right, next thing I'm going to do is set up the channels for reading the encoder and the gyro. Right click, pick up WPI Robotics Library. These are both sensors, so I'm going to pin the sensor folder here, go into the gyro folder, get the ref name for the gyro, use the reset, and then the get angle. And then I want to do the same thing for the encoder. Get the name, the channel name, put the reset in here, and then get the distance. I can close that. Now I'm going to hook these up and then come back at this. All right, so I've made the connection between these blocks for the gyro. Because we have a single gyro, I'm going to create a constant name and use the default that we get when we just do create a constant. But here I need, because I have two gyros, I need to be specific. So my constant's going to say the name of the channel, which will be left E encoder. Now I want to read the angle into gyro angle on robot global data. So as I do that, I pick gyro angle here. I take the distance or the angle, connect it there, and everything looks copacetic. I'm going to take a copy of this, hold down Control, left click and drag, and pick out left encoder and hook it to the distance out of my my encoder channel. All right. Now, first of all, I want to deal with this reset thing. I use a case structure. So if we go right click into program, the case structure is the one with the question mark. Left click and drag and close both of these. When this signal is true, I want to reset the channels, which include the gyro and the encoder. And I want to do that before I use them in measurements. So we'll talk about that in state machines. In the false case, I want to just have them connected so that they're not reset and they're recording the values into robot global data. Now, what do we do with this control signal? I'm going to take a copy of this button, hold down Control, left click and drag, bring it up here, change it, right click with the arrow on here, change to read, and then select my reset signal. Now when the reset is true, these will be reset, and when it's false, they'll be reading the value. Now in terms of signal conditioning, the values that come out of the direction go positive when the motor's moving one direction and negative when it's moving the other. I will have, normally you use this to check to make sure you're going the right direction. When I'm in using automated direction or drive, I know precisely which direction I'm moving, so I'm not gonna worry about whether this is a plus or a minus. I just want to know the absolute value. So I'm going to delete this signal line, do a Control B to get rid of that busted line. And for my numeric palette, I'm going to use a function called absolute value, which will always give me the positive distance that I can then use in my motor control later on. Now, the one thing I want to do in every case, and I want to emphasize it in this webinar, is I need to write these values to the dashboard. So up here we're writing the joystick values of the axis with the network table right array, and I'm going to write these numbers to the joystick, to the dashboard as well. So we're going to go to the right click, robotics library, we go to network tables, and then write. I'm going to put this here. It's going to be write a number. I'm going to put another one up above, hold down Control, put it right here. And so each of these will be writing a separate number to the dashboard. And so I can read from the dashboard the value while we're running the program. And I want to make sure I put a name that I can recognize when it gets to the dashboard. So we're going to call this left ENC. And the same thing up here in the gyro angle. Now you'll see, we'll get in other videos, I actually talk about do single conditioning on the gyro, because the gyros display plus between -90 and +90 as far as the display, but we need to have signal conditioning, and we'll probably do that in the dashboard itself. So let's move this back and give ourselves room for a label. Right click, create a constant. And these labels are strings, so I'm going to call this gyro angle. Okay, so what have we done so far? We've read the gyro value, we've got the angle, we put it into robot global data, and we've also written it to the dashboard, likewise for the encoder. Now, real quickly, refresher, this was an existing loop that I relabeled read sensors and joystick. I call it loop A. I've changed the time. This originally was 10 milliseconds. I've slowed it down to be 20 milliseconds, but that's plenty enough time to read all the sensors and not slow down our execution. And at this point, I'm good to go. Now, there may come a time where I have additional sensors that I need to set up. It could include limit switches. It could include robot or ranging, ultrasonic ranging devices. It could include potentiometers, but we'll handle them exactly the same way and save everything to robot global data. All right, so good luck this season. Email if you got questions. Have a good one.